Hello everyone, good afternoon. Welcome to Best Practices for Amazon S3 Replication featuring HBO Max. I'm Ankita Mishra, I'm Senior Product Manager with Amazon S3, and today I have with me
Ian McGarry, Senior Manager of S3.
And we also have one of our great customers.
Hello everyone, my name is Abhijit Gowda. I'm an architect with Warner Brothers Discovery. I'm part of the media supply chain organization for HBO Max.
Thank you, Ian. Thank you, Abhijit. We'll see you in a bit. Before we start, let's quickly go through our agenda while I grab my clicker. Okay, so in today's session, we will talk about how Amazon S3 Replication works. We will walk through some of its benefits, and then we will drop in some best practices along the way. We will then work with Ian to build a fully functional multi-region storage solution using the features of S3 Replication. And finally, we have Abhijit taking us on a journey of how Warner Brothers Discovery uses Amazon S3 Replication today to build and maintain a resilient business at scale. So we have a lot of content for you here, and we will be open at the end for some questions. But if we don't get to something that you were looking forward to, we will be available in the corridor, maybe after, for some questions. With that, let's dive right in. So at Amazon, we always work backwards from the customer. So before we talk about Amazon S3 Replication, let's answer why customers replicate data. As more and more enterprise customers are moving to the cloud, we notice some patterns in which they are deploying their storage. These customers have the business need to keep their data distributed across multiple locations, closer to the end users for low latency access, and closer to their compute infrastructure. We also see them having an isolated copy, which is protected from any malicious activities. Overall, it is essential for these customers to replicate data for three primary reasons. First, to ensure business continuity by having a backup copy that they can fail over to in case of any disruption. Second, to minimize access latency for their end users. And third, to be compliant with regulatory and data residency requirements. These are some of the patterns that we are working backwards from when we build Amazon S3 Replication. S3 Replication is an elastic, fully managed feature to replicate new and existing objects between source and destination buckets. S3 Replication gives you the flexibility to replicate within the same region with S3 same region replication and across different AWS regions with S3 cross-region replication. You also have the option to replicate to a different storage class at the destination to optimize your storage costs. Additionally, we offer support for all types of encryption, including server-side encryption with Amazon S3 managed keys called SSC S3, server-side encryption with KMS keys stored in the AWS Key Management Service called SSC KMS. And recently, we've added support for server-side encryption with customer-provided keys called SSC-C. Using S3 Replication, you also get the functionality to replicate to a different AWS account at the destination for controlled data access. You can also choose to replicate parallelly across multiple destinations. And earlier this year, we launched S3 Batch Replication to help you replicate the objects that are already existing in your S3 buckets. Finally, S3 Replication offers reliability with metrics and events to help you track minute-by-minute progress, and with features like S3 Replication Time Control, which is backed by an SLA to replicate 99.9% of objects within 15 minutes. And if you wish to configure a multi-region storage solution, S3 Replication can help you easily build and maintain it with S3 multi-region access points. These provide a single global endpoint for multiple buckets in different AWS regions. What's really powerful, though, is that you can mix and match these different features of S3 Replication, and you can also customize each replication rule to suit your business needs. With that, let's now dive deeper into the building blocks of Amazon S3 Replication. One of the top reasons for customers to replicate data is for data protection. To maintain an isolated copy, customers can choose to replicate across regions and accounts. But where do they get started? To get started, customers need to first set up a replication configuration on their source S3 bucket. This configuration can apply to the entire S3 bucket, or you may choose to replicate selectively using prefixes and object tags. Each replication configuration can have multiple replication rules. And each replication rule can have different settings enabled, like delete marker replication, replication metrics, and so on. In our example here, we see that our customer has their primary bucket in the US East 1 region. Let's say the customer uploads petabytes of data into this bucket and saves it in the S3 standard storage class. Let's now start by building a simple replication rule to replicate cross-region from US East 1 to US West 1. In our example, we see that this new replication rule has an ID. We call it the data protection rule. And it also has a bucket arm. This is the bucket in the destination US West 1 region where objects will be replicated to. Now, this is a simple cross-region replication rule. Alternatively, you can create a similar rule for same region replication by replacing the bucket arm with another bucket which is in the same region as the source bucket. Now, let's talk a little bit more about the destination. Let's say this customer is replicating this data for archival purposes. And in this specific example, the customer chooses to change the storage class at the destination from S3 Standard to S3 Glacier Deep Archive to optimize their storage cost at the destination. To do this, they have updated their replication rule, and under the destination field, we see that the storage class is called S3 Glacier Deep Archive. Alternatively, customers can also choose to replicate to S3 Standard, S3 Intelligent Tiering, and S3 Standard Infrequent Access storage classes, among others, depending on the data access pattern at the destination. For additional protection and controlled ownership of data, you can also choose to replicate to a different AWS account. Replicating cross-account can help protect your data against malicious activities and data corruption. In our example, we see that under the destination field, we have an account ID and a bucket arm. This is the new destination account and a bucket in that account where objects will be replicated to. Now, we already know that this customer has a secondary copy of their data in the US West 1 region. Next, let's imagine this customer wants to expand to a new geography. Let's say to the EU West 2 region or the London region. To minimize access latency for their end users in this new region, the customer now has to synchronize their data to the new dev buckets in this new region. How do they do that? To do that, they have to add a new replication rule to replicate from the same source to this new destination. In our example, we can see that the customer has added a new replication rule to their existing configuration. We've called this rule minimize latency. It is enabled by default, and it also has a bucket arm. This is the bucket in the new destination, EU West 2, to which objects will be replicated. Now, this is what a multi-destination replication configuration looks like. We have two enabled replication rules to different destinations. Now, every time a new object is uploaded to the source bucket in US East 1, it will use both the data protection and the minimized latency replication rules to replicate parallelly to the corresponding destinations. Now, the minimized latency replication rule, let's double click on that one. This replication rule will only replicate the new objects that are uploaded to the source bucket to the new destination. But what about the objects that existed in the source bucket before we started replicating to this new destination? Cross-region replication rules do not act retroactively to pick or replicate objects that existed before these rules were created. So that's a problem, right? How would customers replicate the objects that are already existing in this case? Worry not. To solve this problem for our customers, we launched S3 Batch Replication earlier this year. Like in our example, many S3 customers have objects that exist in their source buckets before any replication configuration was created on it. Apart from new objects, customers need to replicate these existing objects as well to hydrate their newly created buckets in case of global expansion, to migrate data across regions and accounts for data protection and better manageability, and finally, to re-replicate objects that previously failed to replicate for misconfigurations or permission issues. This is where S3 Batch Replication becomes super useful. Since batch replication is pretty new, I thought I'd walk you through how it works in a little detail. Let's start with how a batch replication job is configured. There are actually two ways to do it. The first way to configure a batch replication job is as part of your replication setup. That's when you're creating a brand new replication rule on your source bucket, or when you're adding a new destination to your existing replication configuration. That's when Amazon S3 will show you this prompt on your S3 management console, asking you if you want to replicate the objects that are already existing in your source bucket. This right here is the easiest way to create a batch replication job. And in this case, Amazon S3 will use the existing replication configuration to list the objects eligible for replication. The second way to create a batch replication job is as an ad hoc operation. We recommend you to take this route if you want to set up a batch replication job from scratch and play around with additional job settings. To create a batch replication job in this process, you will have to first tell us which objects you want to replicate. You can use an S3 inventory report, a CSV file, or a batch operations manifest to do so. A batch operations manifest is pretty interesting. To generate this manifest, Amazon S3 will use the existing replication configuration to automatically list the objects eligible for replication. And in this case, you can also provide additional filters, like you can filter objects based on their replication status and their creation date and time. The next step in this process is you will have to tell us where to save your manifest and your completion report once your batch replication job is complete. We always recommend you to save a copy of your manifest and review it before your batch replication job begins. On the other hand, you can use your S3 completion report to audit your batch replication job once it's complete. The final step in this process is to give batch operations the required permissions to replicate objects for you. To do this, you can create a new IAM role using the single-click option from the batch operations console, or you can choose from an existing IAM role that batch operations can assume in your account. And that's it. With these 3 simple steps, you're now ready to run your batch replication job. I'd drop in a quick note here that any batch replication job is built on and runs on an existing replication configuration. Therefore, any filters that you have in your replication rules, like prefixes and tags, those are already factored in when we list the objects eligible for replication. Additionally, a batch replication job runs for all the enabled replication rules in your replication configuration. Okay, I think I gave you a lot of information. Okay, let's take a deep breath and change gears a little bit, okay? Let's move on from batch replication and move to some live replication options, okay? Like same region replication, cross-region replication, and replication time control. For these live replication options, Amazon S3 provides different metrics to help you track progress. Now, when customers want to track the progress of their replication, they are usually looking for 2 important pieces of information. First, how far their destination bucket is behind their source bucket. And second, how much do they have left to replicate in terms of bytes and operations. To give you this information and provide additional visibility into the progress of replication, Amazon S3 provides 3 detailed metrics. Let's first talk about the replication latency metric. This metric shows the number of seconds by which the destination bucket is behind the source bucket. If you have strict recovery point objective or RPO requirements, this is a very important metric to refer to. Next, we have the bytes pending replication metric that shows the number of bytes that are pending to replicate from source to destination for a given replication rule at any given minute. We also have the operations pending replication metric that shows the number of operations pending to replicate from source to destination. Now, the last 2 metrics, what is the difference between them? While we can use the bytes pending replication metric to track the objects, to track replication of object metadata, like delete markers and object tags, we can use the operations pending replication metric. Now, let's closely look at the graphs. We can see that the value for these metrics is highest when replication begins, and it eventually goes down as the number of bytes in the source bucket reduces. This gives you very important information that can help you make decisions like failover, failback, or simply auditing the progress of your replication. It is very simple to enable these metrics. You can do it with a single click on a new or existing replication rule. And if you have S3 replication time control or S3 RTC enabled on your replication rule, these metrics are available by default. You can also view these metrics both on S3 Management Console and on Amazon CloudWatch. Now, let's talk about the S3 replication time control feature, which offers a predictable replication time and backs it up with an SLA. Many S3 customers need an SLA-backed offering for guaranteed performance. That's where we offer S3 replication time control, which is backed by an SLA to replicate 99.9% of objects within 15 minutes. By design, we actually replicate 99.99% of objects in that 15-minute window. This is a very useful feature for customers who have shorter recovery point objective requirements. With S3 RTC, you get a reliable RPO of 15 minutes for your most critical workloads. How would you know, though, that you're making the 15-minute SLA? To monitor adherence to this SLA, S3 RTC comes with two unique events: operations missed threshold and operations replicated after threshold. Let's see how a customer can use these two events to monitor their RPO. Let's say we uploaded an object test.jpg to the source bucket at 9 a.m. In the unlikely event that S3 is not able to replicate this object to the destination in the next 15 minutes, at 9:15 a.m., Amazon S3 will emit the operation miss threshold event. And eventually, when this test.jpg object successfully replicates to the destination, say at 9:18 a.m., Amazon S3 will emit the operations replicated after threshold event. In this case, the first event tells you that replication is running late, and the second event tells you that replication is now complete and how late it was. You can use Amazon SNS, SQS, or AWS Lambda to publish and monitor these events. Even with all this flexibility and functionality that S3 Replication offers, building a multi-region storage solution is still complex. That's where we introduce S3 multi-region access points. While creating a multi-region solution, you need custom regional logic to route requests to the closest bucket. And if you need more advanced traffic management, like latency or failover-based routing, it becomes increasingly difficult to build and maintain. That's where S3 multi-region access points become very useful. S3 multi-region access points are a new type of global endpoints offered by Amazon S3 that can sit in front of multiple underlying buckets in different AWS regions. These global endpoints are not tied to a specific region, but to a specific global host name that can be used to reach multiple buckets. Under the hood, S3 multi-region access points is actually a routing feature that routes requests to the lowest latency bucket, while keeping all the requests on the AWS Global Accelerator Network, irrespective of if the request is internet-based, VPC-based, or on-prem network request. Using the S3 multi-region access points can help you vastly simplify the creation and maintenance of a multi-region storage solution, because you're adding multiple buckets to a single global endpoint. It can also help you accelerate the performance of your requests by routing them to the lowest latency bucket. It helps you centrally configure all your applications by using a single global host name instead of hard-coding specific buckets and specific regions. And last but not least, this re:Invent, we're happy to announce support for an active-passive configuration with customer-initiated failover. With this new feature, customers can now operate S3 multi-region access points in an active-passive setup and can initiate failover to shift their S3 data access request traffic to an alternate AWS region within minutes. With that, I will now pass it over to Ian to use these features to help us build a reliable multi-region storage solution. Over to you.
Thank you, Ankita. Hey, folks. My name is Ian McGarry. I'm a senior manager at S3, and I have the pleasure to lead some of the teams that build the solutions that Ankita just walked us through here. So I'm going to take you through kind of an incremental build out of a multi-region solution using some of the features, because there's a ton there, it's very hard to know where to start. So we'll start very simple and go on from there. So this is my simple setup I have today. In Northern Virginia, I have a bucket. It contains pictures of pizzas, bagels, and cats. And I am serving those to my customers that are on the East Coast of the US. They love it, and I love it, because I'm making money. The interesting thing about this setup is that the actual value I have here is the pictures I have, right? That's where my value is. That's my business. If I lose those, I lose my business. It's not about the infrastructure. It's not about the architecture. It's about the objects that are sitting in that bucket. So for peace of mind, I really want to get those. I want to get a replica to another region so I know I have a backup if I ever need it. And so a very, very simple setup is same account, go to another region, create a bucket, and then start replicating between the two, creating replication rules. Very, very simple. It's the most straightforward, and it's the way to start with S3 replication. And as Ankita introduced us to, the way to get the existing objects synchronized over is to use S3 batch replication. So now what I have is, on the East Coast, I have a bucket containing all my pictures, and on the West Coast, I have the same bucket containing the pictures as well. And if I want, at this point, I could decide to use things like replication time control to make sure that it's catching up as quickly as possible, or I can decide on the other bucket to use things like intelligent tiering, because I'm not using those objects, right? They're just my backup, and so I don't want to pay as much for those. I'm not accessing them as often. So very, very simple setup. But I may have missed a step, or I may have had an opportunity to actually optimize something to get a bit more peace of mind before I started. So let's take a step back. I've got my bucket, got my images in there, and what I did before was I replicated within the same account. But within the same account usually means permissions can access both buckets, right? I can configure them not to, but it usually means that there's a root account or a root user in that account that has access to all those resources. So what could I have done at that point? Well, I could have thought, hey, why don't I try and replicate between two accounts? And the benefit there is that you have a separate permission set in both sides. And so for whatever reason, somebody got into your account A and started deleting objects, or you had a rogue script that was deleting objects from your bucket, it would be very, very difficult for them to also gain access to account B. So the nice benefit of having replication between accounts is that you actually introduce an account-level firewall between the two. It's a best practice we recommend, and it's something you should definitely take into account. There is a few more steps with that. So what does it look like? You can set up the replication rules, as Ankita pointed out, between the two buckets, but you can't just replicate to anyone else's bucket, right? So what do? On the destination bucket, you have to set up some statements within your bucket policy to grant permissions to that source bucket to actually go and replicate. And what does it need? We see a couple of things there. In the first statement, I'm setting permissions for the objects themselves to be replicated. And so what I'm granting access to is an IAM role in the source account saying, hey, you can replicate object and you can replicate delete for delete markers across. That doc example bucket is the bucket that I would like them to be able to have these permissions against. So that is in the destination account. And the source bucket account ID is the source bucket account ID, and the role is from that other account as well. The second set of permissions are the set permissions on the bucket level. So I need a few more requests, or I need to be able to make a few more API calls to achieve this. And so again, it's the previous IAM role, but I'm now granting S3 list star for the various lists I need to run, get bucket versioning and put bucket versioning. So I can make sure they're set up. So this is what the basic policy looks like on the destination bucket. And with that in place, my source bucket can now successfully replicate across. So think of this like a handshake, right? The source bucket wants to replicate. The destination bucket says, I don't know who you are. Why should I allow you to do that? And so you have to come in and update that policy to allow that process to occur. Okay. So again, I now have my cross-account replication. And again, I'm using S3 batch replication to get all the existing objects over. So now in that second account, again, I can have intelligent tiering. I could even put object lock in there as well if I wanted to make sure that that data set was immutable and couldn't be deleted. So it's like a bunker for my data. No one's going to access it. It's replicating there. And if somebody gains access to account A, or I have a cleanup script that goes rogue, I have peace of mind that my data set is in account B. All right, so let's go on a little bit. We have our replication setup. Where do we go from here? Well, we don't have to go anywhere. This is a pretty good setup. You have peace of mind. But let's take it a bit further. Multi-region access points, we launched last year in September of 2021. Multi-region access points, the benefit are they're a single global endpoint that you can stick in front of your buckets, right? But what does that mean? Let's take a quick look at some of the stuff behind the scenes. So here I've run a simple dig command on the endpoint, and at the very top of that terminal you can see the endpoint for my multi-region access point. It's a bit of a mouthful, but you'll see in there the keyword S3-global. That is the new endpoint. Most of the endpoints we have in S3 are namespace to the region. This is an S3-global endpoint. What else is in there? In the orange box, I've highlighted that the static IP addresses for your multi-region access point. You get 2 for redundancy. But what are these IP addresses? These are not actually S3 IP addresses, interestingly enough. These are Global Accelerator IP addresses. The beauty of Global Accelerator is it's a distributed network of edge locations that can advertise IPs all over the place. So these IPs are actually advertised at multiple edge locations and can attract my S3 traffic. So here, Global Accelerator IP addresses, not necessarily S3 IP addresses. That will be important in a second. Here is a map of all the edge locations for Global Accelerator. There is, at the moment, 104 points of presence across 88 cities in 48 countries. I think I have all those stats right. So you can see it's a globally distributed network. And what's the benefit of a Global Accelerator or having those 2 IP addresses? Well, those 2 IP addresses are advertised at all of those points of presence. So if I have consumers in South America, their request is actually getting routed to points of presence in South America, not necessarily in US East 1, Virginia, where I actually have my bucket. The cool thing about that is we attract the traffic very quickly onto the Amazon backbone network. That's the real beauty of this, is that you get on there very quickly. We actually terminate TCP at that edge location and then create a new request almost instantaneously to S3. And then all that traffic gets routed straight over our backbone. So that's the beauty of a multi-region access point in terms of global access. So what does it mean for us? Well, for us, it means I can now expand quickly to the West Coast, right? So I've expanded from pizza and bagels and cats to dogs and surfboards and everything else on the West Coast that I'd like to advertise. So I now have images from both locations. And what I've done is I've actually started using this bucket. So it's not a replica anymore, although it is a replica of the data, but I'm actually getting value from it now. That's a really cool and powerful thing. And I've set up bidirectional replication between the 2 because I now have users on the West Coast accessing and uploading images that people on the East Coast are going to want to access. I'm bringing the coasts together. So I have bidirectional replication set up. I have an active set up between the 2. And now any requests from the West Coast are being routed to edge locations on the West Coast and then taken to the bucket on the West Coast in Oregon. Any requests on the East Coast are now being routed to the bucket on the East Coast by being picked up by an edge location on the East Coast. And let's say I have some more users in the rest of the world. I'm from Ireland, so I want to start looking at pizza and bagels on the East Coast. You can imagine if I am in Dublin looking at these images, I'm actually being routed to the East Coast, right? Rather than all the way over to the West Coast, that would be pretty far to go. Dublin is across the Atlantic, and so I'm being routed over the East Coast. Now, if I wanted, I should, as an owner of all of this, I could expand and put another bucket in Dublin and go on from there. So that's a really powerful way of using multi-region access points to take advantage of your data replica. It's not just a static data set anymore. It's actually allowing you to expand globally. And you're getting that accelerated performance I just mentioned. Now, what does this slide mean? Well, imagine a situation where someone in the middle of America drives a large stake through some cables, right, or cuts through them. Someone crashes into a pole, or someone's digging up a field and cables get cut in half. Now, folks on the West Coast are not able to access my data replica on the West Coast. They're being routed there, but they're not able to access it. Well, what's going on? When that happens, Global Accelerator is able to detect that you're not able to reach S3, or it's not able to reach S3 from its edge locations, and will now reroute all of that traffic over to the East Coast. So you are getting a bit more latency, but you're on the Amazon backbone network, so it's faster, and you've recovered immediately without having to do anything, right? This is a really, really powerful attribute of multi-region access points as well, is that they give you failover. And this could be anything. It could be undersea cables cut. It could be cables cut between the two. It could be internet weather, congestion. Lots of things are covered by Global Accelerator's ability to detect when your requests are not performing as they should, and they get sent over to the East Coast. It also detects latency, so for whatever reason, it's able to access it, but it's very, very slow. It will say, okay, it's probably go faster to go to the East Coast. For whatever reason, I can't get you to Oregon. So another very powerful aspect of it. So this is my active-active setup. So just to recap, I've come from one bucket to replicating 2 buckets in the same account, to replicating 2 buckets across account for extra security, to now taking advantage of my second data set or replica. So I'm not just having it sit there. And Keita mentioned this a minute ago. We just launched on Monday S3 multi-region access points failover controls. It's a long name, but a very powerful feature. What does that give you? It gives you the ability to decide when you want traffic to be routed from one location to another. We're calling it failover controls because that's what we expect most customers will use it for. But really what we're giving you is an active-passive setup. You can create a multi-region access point with up to 17 regions behind it, and you can have 16 of those passive, 1 of those active. You could have 5 active, 5 active, 12 passive. It's really up to you. The only restriction is that you have to have at least 1 active at all times. So multi-region access point failover controls, what does it look like? Let's take a look. Well, this is actually the console experience for failover controls. So you have a nice map, and you can see my bucket on the East Coast and my bucket on the West Coast. So this is where my photos are hanging out. So here on the East Coast, I've actually set this to active now because I want all my traffic to route to the East Coast, and I want my second bucket to be the backup just in case I need it. And you can see active in brackets beside the US East one or the Northern Virginia bucket, and you can see passive beside the other. What does it look like to actually conduct a failover? This is it. Select your 2 regions, click failover, brings up a dialog box, just giving you some information about what's happening. But the main takeaway there, thing to think about is, it takes 2 minutes for new traffic to start routing. That's very, very quick failover and recovery. You can imagine this, if you start getting requests saying, hey, can't find images, or we're getting 404s from a bucket on the West Coast or on the East Coast, you say, oh, maybe someone's actually done a cleanup script or run a cleanup script that went a bit too far. You can think, okay, let me react. Let me go and use my second data set. So you go into the console, click failover, and within 2 minutes, the traffic will be routed over to the West Coast. This is just the console experience. Obviously, there's APIs available in the CLI and SDK as well. And this failover API, because it's so important and critical, because we know you're only going to push it when you need to, it's available in 5 regions. So wherever you are, you have access to that API. So I've clicked that failover button, and now I can see on the map, my Oregon bucket is my active bucket, and my Virginia bucket is my passive bucket. So this is new, launch Monday. Please do check it out. So what does this look like back on my little map or my architecture? Well, at the moment, I have all my traffic routing in an active fashion to Northern Virginia, US East, and you can see my passive bucket, Oregon, is grayed out. Again, up to 17 buckets, so you can have quite complex architectures here. This is just simple for today, but you can go as expansive as you want on this. There you can see a failover occur, and you get to switch when you decide. The last thing I just wanted to walk you a little bit through is something that I think is very, very neat aspect of multi-region access points. And if you take away anything today, think about this. Here I have actually set up a multi-region access point, and I'm showing you a little bit about behind the scenes about how it works. If you look there, I have an EC2 instance going through a VPC endpoint, going to Global Accelerator, going to S3. That's essentially what a multi-region access point is when you use it from within your VPC. You set up a private link endpoint, and that then routes traffic to Global Accelerator, which then will route it across region. Very cool thing about multi-region access points is you can actually set them up with just one region behind them. Now, you don't get the failover controls I just mentioned because there's nothing to fail over between. However, what is this bucket now for, this single region or multi-region access point for? Well, it's giving you access to data in another region. Cross-region access for S3 is achieved through either an internet gateway, or you can achieve it by setting up a VPC private link endpoint for S3 in the other region and peering your VPCs, or you can use something like transit gateway. Those things work, but they're also sometimes difficult to set up, especially if you've got many VPCs in a complex architecture. This allows you to create a multi-region access point in front of a bucket, create a private link endpoint, and away you go. You now have cross-region access from within your VPC. And with private link, you have a private IP address as well. So you can keep things locked down, and you have a VPC endpoint policy. So you can say, hey, within my VPC, I only want to allow access to this multi-region access point. So a very neat way of doing cross-region S3 access if you need it, without having to do either VPC peering, transit gateway, or setting up an internet gateway. Internet gateway works too, but internet gateways allow access to everything on the internet. With an interface endpoint or an Amazon VPC endpoint, you get a policy that locks it down to specific resources you would like to access. All right, that is all from me, and I'll hand it over right now. Thank you, folks.
Thank you, Ian. I'm Abhijit Gowda again, and hope everybody is actually having a great time at re:Invent. Today, I'm excited to share how Warner Brothers Discovery uses Amazon S3 Replication to ensure business continuity for our HBO Max content libraries at scale. HBO Max is Warner Brothers Discovery's direct-to-consumer platform offering the best-in-class quality entertainment. We are one of the leading streaming services here in the United States and globally with our service in 61 countries. Any HBO Max subscribers in the room? That's awesome. Thank you for those in the room and the many millions of consumers across the globe. We appreciate your business. So, what do we do at Media Supply Chain? We are the media processing factory of Warner Brothers Discovery. Media enters our workflows on one end. We process that media based on a variety of specifications, and the finished media assets are then delivered to our linear and direct-to-consumer platforms, in this case HBO Max, on the other end. We decouple our storage and compute, which actually provides us agility, scalability, operational efficiencies, and cost benefits. We run hundreds of microservices in production as part of our media workflows, mostly on AWS Lambda, ECS Fargate, step functions, and Amazon S3. Some additional information around the scale at which we operate before I dive deep into our today's topic. We are a storage-heavy organization. In fact, majority of media and entertainment companies are, with tens of petabytes of our primary content storage and an additional tens of petabytes of content backups. Our storage footprint on S3 is massive. So, what does such a scale of S3 mean? A big fat AWS bill. Fun aside, such a scale of storage comes with a great responsibility to protect these petabyte scale content libraries to ensure business continuity. Protection from two things: protection from theft and protection from data or content loss. Today's presentation focuses on the latter, which is to have a secure and cost-optimized copy of our content for disaster recovery. So, content is king, and as a media and entertainment company, content is at the center of our business. Many of you are HBO Max subscribers. Did you all enjoy the House of the Dragon Season 1? That was spectacular, wasn't it? I'm very sure that majority of you and the rest of the world, you're eagerly awaiting for Season 2. Let's imagine a hypothetical situation wherein our company has to make a public announcement saying, sorry folks, the Season 2 release is actually delayed due to content loss. That compromises our brand reputation and also our consumers' experience. Alongside planned release schedules, it also negatively impacts our rollouts into newer territories as we continue to grow globally, not to mention the revenue impact it might actually have on our company due to such an event. There are costs associated with content acquisition, processing, and delivery. These costs can be acquisition costs from our partners, transcoding costs, compute costs, human effort, and so on. Reproduction of lost content is both time and cost prohibitive. Anything that can go wrong will go wrong at the worst possible time. And we actually had to think about what those worst possible scenarios are. So following are the disaster scenarios we accounted for while we were actually building this backup solution. Accidents can happen anytime. It can be due to human errors or even rogue employees wiping our primary content libraries clean. Even an improperly tested production deployment can result in undesirable situations. The open internet is hostile. Hackers and bad actors, they might actually destroy our primary content store or even lock us out of them and hold our company to ransom. It has historically happened in other media and entertainment outlets. Even though rare, cloud services might fail. Even a single service failure or an entire region failure might require us to fail over to a different region or a secondary region and resume business operations. So without a proper content protection strategy, our primary content libraries are at risk. An immutable cross-account and cross-region backup was actually the need of the hour. So how do we back up our content? Our content is distributed across multiple AWS accounts based on content classification and use cases. We have set up a unified backup account, and our backup solution uses a many-to-one model from an account's design standpoint. The backup account security is hardened following AWS and industry-recommended best practices. We have enabled S3 inventory on the source buckets, which generates a daily inventory. These are also replicated to the backup account and are later used for recovery purposes. And we also use Amazon S3 Replication to achieve this. The daily inventory provides a 24-hour RPO from an ease of recovery standpoint. Even shorter RPOs can actually be achieved using custom-built inventory generation processes. Our automation modules couple the source and the backup buckets from a deployment and operation standpoint. And through our replication rules, we set the destination storage class to Glacier Deep Archive to optimize our backup costs. We also disable delete marker replication to ensure malicious deletions do not make it to the backups, so it actually helps us to reduce our mean time to recovery. The backup buckets use object locking in compliance mode, which provides immutability. As part of the initial backup, a one-time existing objects replication is achieved through S3 batch replication job. From this point, replication is both continuous and real-time with a SLA of 15 minutes using replication time control. We also enabled S3 server access logs and consolidate the logs in our observability account, which are later ingested to AWS OpenSearch for log analytics and monitoring purposes. We also requested our dragons to protect our backups. Scary, huh? So now that we have created a secure backup of our critical content, let me double-click on our recovery process in case of a disaster. Recovery is either a one-step or a two-step process, depending on your DR scenario. In case of recovering and resuming business operations in the secondary region, we perform the following. Identify the S3 inventory files, meeting our RPO. Depending on if we are actually doing a full restore or a partial restore, these S3 inventory files are used as is or actually updated to account for your recovery scope. The S3 inventory manifest is used as an input to a S3 batch operations restore job, which restores all of these objects from Glacier Deep Archive. At this point, we can connect our workflows to these backup buckets and resume business operations. When these restore objects are actually required in the primary region, we will actually run another S3 batch operations copy job. What that does is it actually copies these restored objects from the backup account back to the primary account and region and onto the primary buckets. And from there, we actually resume our business operations. So we have actually realized the following benefits by implementing a content backup strategy using Amazon S3 Replication. It is very simple and easy to operate on, and most popular infrastructure as code tools actually have full support for all the features we've used in our solution. And we have also achieved full automation from a backup and restore standpoint. Using Glacier Deep Archive, our backup spend is 1/7 the cost of our primary storage spend, which is significant considering our scale. It is fully compliant with our CISO guidelines and all applicable industry compliance requirements. Through object locking, our backups actually provide write once, read many compliance and are truly immutable. Considering that they are cross-account and cross-region, they actually provide full coverage for all of our envisioned DR scenarios. And with a less than 15-minute RPO and a less than 24-hour RTO, it actually fully satisfies our RTO and RPO requirements. And these backups are continuous in nature and incremental for anything new which is landing in our source buckets. So, and our backup lifecycle management itself is policy-driven. And using S3 server access logs and replication time control and those logs actually ingested in AWS OpenSearch, our backup and restore processes are fully observable. And this is how Warner Brothers Discovery actually has implemented a backup strategy to secure our HBO Max content libraries to ensure business continuity at scale. Thank you for attending. Over to Ankita for the key takeaways.
Thank you, Abhijit. Seems like HBO Max is making good use of S3 replication to protect their data, and so can you. Now we'll wrap it up and summarize some key takeaways from today's presentation. So, Amazon S3 replication provides unique features like replication metrics, replication time control, and replicating parallelly across multiple destinations to satisfy compliance, improve resiliency, and optimize performance while storing multiple copies of your data. If you need a reliable RPO for your business, we recommend you to use S3 replication time control, which comes with metrics and events to help you track progress and is backed up by an SLA to replicate 99.9% of objects within 15 minutes. Now you can also replicate the objects that are already existing in your account with S3 batch replication. And finally, you can use S3 replication with S3 multi-region access points to simplify building a multi-region storage solution. With that, I'll encourage you to learn more about Amazon S3 replication. Scanning this QR code will take you to our public documentation. And you could also dive deeper and learn more about AWS Storage on your trainings and badges with the link on your screen. With that, I thank you all for attending today's session. I hope it was useful. And you'll already have a session survey in your inboxes. We'd love your feedback on today's session. And if you have any questions, we're open for now. Thank you.